Hello and welcome to AP CSA Prep. Today we're going to review the entire AP Computer Science A curriculum in just 30 minutes. So, without further ado, let's get started. Before we begin, let's have a quick overview of the AP exam format. The CSA exam has two separate parts. First, we're going to have a multiple choice, which consists of 42 questions, making up 55% of your score. And second, we have a free response section with 4 questions, where it's 25 points total, making up 45% of your score. Now, let's get started with Unit 1, using objects and methods. First, let's talk about an introduction to algorithms, programming, and compilers. An algorithm is essentially a step-by-step procedure for solving a problem or completing a task, and programming is the process of creating instructions for a computer. A compiler is essentially a program which translates Java source code or code that you write into bytecode, which a computer can read and execute. For APCSA, you have to understand the program design process. The design process consists of 4 steps. First, you have to understand the problem. Second, you plan the solution. Third, you implement the code. And fourth, you test and debug. Since there are no conceptual free response questions on the CSA exam, you won't ever need to articulate this process, but make sure you have a good understanding in order to effectively answer the FRQ programming questions. Okay, now let's get started with variables and data types. Data types are just different formats for data to be stored in. Think of numbers or words. In Java, data types can be either primitive, which are built-in or simple, or non-primitive, which are complex. We're going to go into each of the separate data types in a bit. Essentially, in Java, there are 8 primitive data types, but for APCSA, you're only going to need to use 3 of them. And there's only one non-primitive data type that you will interact with on the AP exam. Variables are essentially like boxes. One of my favorite analogies is that just like you might have a box labeled toys that can hold all of your childhood toys, a variable called age could hold the number 10, representing your age if you were 10 years old. In Java, variables are symbolic names that can store given values. We use variables to work with values that are not fixed or that change over time, such as receiving input, doing math, or storing fluctuating data. There are many types of numerical variables in Java. The first type is a byte, which represents one single number or one single digit. A short is essentially 2 bytes that can represent a two-digit number. An int is 4 bytes, so that can represent up to a 4-digit number. A long is 8 bytes, meaning that it can represent up to an 8-digit number. A float is 4 bytes, but it can include decimal places. And a double is essentially the same as a float, but it can hold up to 8 bytes of information. The non-primitive variable that you're going to need to use for APCSA is a string. String variables contain sequences of characters, such as hello or how are you. A special subset of the string variable is a char or character, which contains a single character. Char variables or character variables are not tested on the APCSA exam, so you don't need to know how to use them. Another type of variable is a Boolean variable. A Boolean stores either the value true or false, and it can be used in conditionals and if statements, which we're going to explore later on in the lesson. To create a variable in Java, you're going to have to specify the type of variable before you create it. In order to assign a variable a value, you simply use the equal sign. Here we have an example of a string variable called name, which has a value of John, or an int variable called age, which has a value 12. To use a variable, you simply have to reference its name later on in your program. Let's say you wanted to print out your variable that stores your name. You could do something such as system.out.println. Your name is plus name. Variables can be combined with other data of the same type using the plus sign. In this case, we're combining the string your name is with the variable name in order to get a combined string of your name is John. This can also work with numerical variables. However, with numerical variables, the plus sign will add the variables together. Not all variables can be used together. Make sure that when you're using variables, they're all of the same type, all strings or all integers. Otherwise, you might get an unintended result or an error. Some other important variable rules that you need to know include that variables must be declared before they're used. Variable names are case sensitive. Variables cannot use Java keywords. And variables should use the camel case convention. However, that's more of a norm and not a specific rule that you have to follow. In Java, Boolean variables can only be assigned the values true or false. Unlike other programming languages you might have used, such as Python for APCSP, Boolean variables cannot be assigned values such as 0 or 1 in order to represent true and false. You have to use either true or false, all lowercase. Here we have an example Boolean variable, myvar, being set to the value true. Another important concept for APCSA is autoboxing. Autoboxing is the conversion of primitive data types into wrapper class objects, such as an int into an integer, a double into a double with a capital D, a boolean into a boolean with a capital B, or a car into a character with a capital C. Autoboxing is used for data structures such as array lists, which only accept objects and not primitive values. Autoboxing happens automatically, hence the name, so you're never going to have to directly do anything special in your code in order to make this happen. Now, let's move on to objects. An object is a specific instance of a class, containing real values instead of variables. Objects have state and behavior, which means that they have attributes or properties that belong to that specific object, and behaviors, which are methods or functions that belong to the wider class. Let's take an example class called animal. The code for the class can be seen here. To create an object, you first declare the type, the name of the class, and give the object a name, similarly to a variable. In our case, we can use animal and we'll name the object pet. Then you can use the equal sign to assign a value. To create a new object, you use the new keyword along with the class name and any parameters. In our case, the parameters required for our class are the species, color, and age. So in this case, we're going to pass in dog, brown, and the number 2. You can create as many objects as you want of one class, but remember, each object is considered a separate entity. To use a command from the class of your object, you first use the name of your object, in our case pet, and then call the command like you would a regular method. In this case, if we wanted to display the details of our pet object, we could use pet.displayDetails, as displayDetails is a method declared in our class. You can access properties of your object the same way you would access a method. The code below shows how you'd access the color property of our object. You would essentially use pet.color. The pet.color value is treated like a variable in Java. However, the value is being referenced from our class object of pet. Nearly all classes in the APCSA exam use private variables, so you wouldn't be able to edit or reference the values directly like this. If you want to modify the properties of your object like a variable, you would simply use the object name .property and use an equal sign to set it to a new value. However, remember, APCSA uses private variables for most of its problems, so you would not be able to edit the values directly like shown here. Now, that covers the most of Unit 1, so let's do some practice questions before we move on to Unit 2. Take a look at this question, and you can pause the video if you want a moment to solve it before I move on to the answer. Okay, so the answer for this question is B. Let's do another one. Pause the video now if you want a moment to solve this question. The answer for this question is B. Let's do another practice question. Pause the video if you want to take a moment to answer this question. The answer to this question is B. Let's do another one. Pause the video now if you want to take a moment to answer this question. The answer to this question is A. Alright, now that we've done some practice questions for Unit 1, let's move on to Unit 2, Selection and Iteration. Unit 2 represents 25 to 35% of the AP exam, so it's definitely a large part of what you'll see on your exam. First, let's talk about Booleans. A Boolean equation is an equation used to evaluate conditions. Boolean equations always result in either true or false. In the example below, the equation would result in true if the variable a was equal to apple, and false otherwise. Boolean equations use special operators, called Boolean operators, in order to compare two values and result in either true or false. The greater than operator compares two values, a and b, and results in true if b is greater than a. Likewise, the less than operator results in true if b is less than a. Greater than or equal to, or less than or equal to, are essentially the same as the greater than or less than operators, but they also check if the value b is equal to value a. The double equal sign represents the equals to operator, which can be used to check if two values are the same. Exclamation mark equals is the not equal to operator, and that can be used to check if two values are not the same. The logical OR and logical AND operator compare two values. Logical OR will result in true if you have at least one of the two values being true. However, logical AND will only result in true if both of the values are true. The logical NOT switches the value of a Boolean, so if you have not true, you would get false, and if you have not false, you would get true. In Java, the equals operator, which is two equal signs, works differently for primitives and objects. For primitives, the equals operator checks to see if two items have the same value. For objects, however, the equal sign checks if they are the same object, regardless of their value. For objects, you can use dot equals instead of the double equal sign. An example of using dot equals is shown here. Let's say we have two objects, A and B. We can use A dot equals B in order to check if A and B have the same value. Because if we were to use the double equal sign in this case, if A and B are two separate objects, both with the value 5, the double equal sign would result in false because the objects are not the same, they're distinct objects. However, dot equals results in true, as dot equals is comparing the values of the two objects, which both are equal to 5, meaning that they are essentially the same. Now, let's talk about conditionals. Conditionals, also known as if statements, can be used to execute a piece of code if a certain condition is met. In this example, we have a string, which is hello earth, and we are checking if my string equals to hello world, then system.out.println my string is hello world. In this example, the code won't do anything, as the string my string is equal to hello earth and not hello world. If we changed my string to hello world, then our print statement would execute, and this code would result in my string is hello world. Else statements can be added after an if statement in order to specify what to do if the condition is not met. Take, for example, our string being equal to hello earth. Our if statement in this case would not execute, as my string is not equal to hello world. but that would cause our else statement to execute. So this code would result in my string is not hello world. We can also add else if statements. An else if or elif statement can be used to provide a secondary condition if the first one is not met. The code here shows an else if statement. If we were to add an else if statement between our if and else statements, we could check for a secondary condition. Let's say if our string is equal to hello earth. In this case, this code would result in my string is hello earth, as our else if statement would trigger due to our string being equal to hello earth. Now let's move on to loops. Loops are used to repeat a piece of code without having to write it multiple times. In Java, there are two types of loops. For loops repeat a certain number of times, while loops repeat as long as a condition continues to be met. In Java, for loops are initialized using the for keyword and by specifying 3 commands between parentheses. The first section specifies what to run when we enter the loop. The second section is called the gatekeeper. If it returns true, then we run the loop. If it returns false, then we exit the loop. And the third and final section is the statement that runs every time the loop runs. In this case, we have a for loop. Our first condition is int I equals 0. So when the loop first initializes, the int I will be set to 0. Our gatekeeper in this case is I is less than 5. So as long as I is less than 5, this loop will run. And at the end of each loop, we have I++. So each time this loop runs, I will be incremented, or 1 will be added to the value of I. In this case, our loop is essentially printing out the value of I. So we would first print out 0, then 1, then 2, then 3, then 4. And then our value I will be equal to 5. And since 5 is not less than 5, we would exit the loop. So this loop essentially prints out the numbers from 0 to 4. For loops can also iterate over data structures such as arrays. We're going to talk about arrays in a bit, but essentially when iterating over any data structures, you have to declare a variable, which can be used from inside your loop to reference the current element of the array which is being run upon. This variable will contain each element in your data structure sequencing with each iteration. Let's say, for example, we have an array that has the following values: 0, 1, 1, 2, 3, 5. If we have a for loop, we can declare it with int I, my array. The colon operator in this case declares that int I should iterate over each value in the array my array. So in this case, this loop would print out 0, 1, 1, 2, 3, and 5, which is each of the elements in my array. While loops are created using the while keyword and a repeat condition which is specified within parentheses. As long as the repeat condition remains true, the while loop will keep going. Take for example if we have an integer x which is equal to 10. If we set our while loop to while x is less than 5, system.out.println x minus minus, this loop would run 0 times because our integer x is never going to be less than the value 5. However, if we want the loop to run at least once, even if our condition is not met, you can use a do-while syntax. Do-while loops evaluate the repeat condition after the iteration instead of before, meaning that the loop is ran first and then the condition is checked to see if the loop should run again. In this case, even though our value x is never going to be less than 5, the do-while loop will run at least once, and it will print out the value 10, changing x to 9. Then, since 9 is still not less than 5, our do-while loop will no longer run. Loops in Java can also use some special statements. One of these special statements is the break statement. The break statement ends the loop wherever it is called. In the example below, the code will only run 3 times, even though the condition is as long as I is less than 6. And this is because when I reaches the value 3, the loop will break. The continue statement is used to skip an iteration of the loop. In this example, the code will run 5 times instead of 6, as when I is equal to the value 3, the continue statement will be used to skip that iteration. That covers most of the lessons in Unit 2, so now let's do some practice questions. Remember to pause the video if you want to work through this question before I reveal the answer. The answer to this question is A. Let's do another one. Remember, you can pause the video now if you want to work through the question before I reveal the answer. The answer to this question is B. Let's do a third one. Pause the video if you want to work through it before I reveal the answer. The answer to this is A. And now the final practice question for Unit 2. Remember, pause the video if you want to work through the question. The answer to this one is B. Now, let's talk about Unit 3, class creation. Unit 3 represents 10 to 18% of the AP exam. So while it's one of the least weighted units, it sets up a good portion of the course as it talks about classes, which are used all across Java. Classes are essentially a blueprint for creating objects. They define the properties and behaviors that objects created from the class can have. Think of a class as a template and an object as an instance of that template. Classes can be of 4 types: public, private, protected, or default, or package private. In AP CSA, you're only going to need to focus on public and private classes. Essentially, public classes are accessible from any other class anywhere in the codebase, while private classes are only accessible from within that same class. Classes are created using the class keyword. The name of the class should start with an uppercase letter, but this is not required, it's just best practice. The example here shows an example class. You can see that we start with the word public to denote which type of class we're going to make. Then we use the class keyword, and then we give the class a name. In this case, we're naming it main. Methods are a block of code that perform a specific task. Methods are used to define the behaviors or actions that objects of a class can perform. And all code in Java has to be written within a method. In Java, a method follows the structure shown here. First, we have the modifier, then the return type, and then we have the method name, followed by parentheses which contain each of the parameters. Then, inside of curly braces, we write the code for that method. Parameters are essentially values that are given whenever a method is called and are used in the function. Parameters allow for the same function or method to be used for different use cases. To define a method, you always have to follow the structure shown in the previous slide. So for example, we can have a public method with no return type, or void, meaning that the method is not going to have any return statement. And we can name this method printinfo. In the parentheses, we can have string name, and this means that we have one parameter, which is a string called name. So then within our method, we would be able to use name as a variable of the string type. In classes, methods are commonly used in order to give the class commands. Some classes include special methods called constructors. Constructors are used to give parameters to a class as a whole. So the code here shows a constructor method inside of a class. The this keyword in the constructor refers to the current object and is used to differentiate between variables and parameters. There are also another type of special method called static methods. These methods are defined with the word static before the return type and cannot be called from an object of the class. Static methods are mainly used within the class itself, as they can be called from within the same class, but not by an object of the class. To output any text in Java, you use the system.out.println command. The system.out.println command has one parameter, which is a string that includes any text that needs to be printed out. As shown here, you can do system.out.println hello world in quotes, and this essentially prints out hello world. Now let's do some quick practice questions for Unit 3. Remember to pause the video while you work through the question before I reveal the answer. The answer to this question is C. The next one, remember to pause the video in order to work through the question. The answer to this question is also C. Now let's do another. Make sure to pause the video so you have some time to work through this question. This one is also C. And finally, let's do a fourth question. Remember to pause the video so you can work through the question. And this one is also C. Okay, now let's move on to Unit 4, Data Collections. Unit 4 represents the largest part of the AP exam. It can be up to 40% of the entire exam and is one of the longest units in CSA. Unit 4 covers key concepts such as arrays and array lists, which are not only going to come up a lot on the MCQ, but also going to be very frequent on the FRQ. First, let's talk about arrays. Arrays in Java are a fundamental data structure that allow you to store multiple values of the same type in a single variable. In Java, you can declare an array without having to assign it any value. To declare an array, you have to specify the type of value it will store along with square braces and the name of the array. For example, here, we can declare an array of integers using int, square braces, myArray. After you declare an array, you still have to create it before assigning any values. In order to create an array, you have to use the new keyword and specify its size. The code below shows the array from the previous example being created. You can do myArray equals new int, and then in square braces, the size of the array, in this case 10. You can also directly create an array by combining the first two steps into one line of code, as shown here. Initializing an array is when you create the array with a specific value. To initialize an array, you declare the array and then assign its value in curly braces. In this case, you create the array with int square braces myArray, and you can immediately set it equal to a list of values in curly braces. Now, once you have your array created and initialized, you can access elements of the array using the element's index position in square brackets. In Java, like most other programming languages, indices start at 0 instead of 1, so the first element in your array would be at index 0. As shown here, we're simply printing out the first element in our array. When you're accessing array elements, you can also modify them just like you would two variables. Make sure that you're using the correct data type, as arrays are locked to one specific data type. You can find the length of an array using the array.length method in Java. This is different from the length of an array list, so make sure you know how to get the length of an array, as it's frequently tested on APCSA FRQs. In Java, you can also create multi-dimensional arrays, such as 2D or 3D arrays. Multi-dimensional arrays are just arrays of arrays. The most common type is a 2-dimensional array, or matrix. In the example below, we're creating a 3x3 matrix. And all you need to do is simply add another set of square braces next to the initial set of square braces. Array lists in Java are another type of data structure, very similar to arrays. The main difference is that array lists store non-primitive objects, while arrays store primitive values only. Another significant difference is that array lists do not have a fixed size, so you can store as many values or as little values as you need. To use an array list, you can import it in your Java file. It is a part of the java.util library. You can import it in one of two ways. You can either use import java.util.arraylist, or you can do import java.util.star. And the asterisk or star basically imports every single class from the java.util library. To create an array list, it's going to be very similar to creating an object of any other kind. However, there's one key difference. The array list class has a special property where you declare the data type. In this case, that is going to be between two braces. So you would have array list, you'd declare the data type as integer, and then you'd give the array list a name, myAL. Then you can set that equal to a new array list. Again, remember to denote the data type, and then put parentheses because you are creating an object of that class. To access elements from an array list, you have to use the .get function. Inside of parentheses, you have to specify the index of your desired element, similarly to an array. Remember, indexes start from 0, so the first element in your array list uses the index 0. To add an element to an array list, you can use the .add method. By default, all elements are added to the end of an array list. To modify an element in an array list, you can use the .set method. The .set method requires two arguments. First, the index to be changed, and then the value to be changed too. For example, here, if we want to change the first element in our array list to the value 2, we can use myal.set 0, 2, where 0 is the index and 2 is the value to be changed to. To find the length of an array list, you can use the .size method. Remember, this is very different from the .length in an array, where .length is a property of an array, while .size is a method that you use on an array list. This means that you need to ensure that you have the parentheses after .size in order to correctly get the size of your array list. While multidimensional array lists are not often used, it is still possible to create them by setting the data type to another array list. So you can do array list and set the data type to another array list of any other data type, and that would create a multidimensional array list. While this is technically possible to do, it doesn't commonly come up in AP-CSA, so you shouldn't be too worried if you don't know how to use multidimensional array lists. Now, let's do some practice questions for Unit 4 before we wrap up. Remember to pause the video so you have a chance to work through the questions. The answer to this one is D. Next, we have this question. Remember, pause the video if you want a chance to work through it. The answer to this one is A. Next, we have this question. Remember, pause the video so you get a chance to work on it. The answer to this one is C. And finally, our last question. Pause the video so you get a chance to work on it. The answer to this one is D. Alright, that's the end of the entire AP-CSA curriculum. Hopefully, after watching this video, you're ready to get that 5 on AP-CSA tomorrow. Good luck.